Yes.
Cool. Okay, so you seen yesterday that our main idea is to host applications, and to host application we need servers, right? And we host every application or every service in different server because we want isolation. Okay, for every service we want an isolation. That is the reason we started hosting every service in a separate server, in a separate physical server, right? But that comes with a lot of cost, money, right? Operations cost, right? So the better option was to go with hypervisor architecture. So VMware was the biggest player back then. Till today is the biggest player in virtualization. So it provides you hypervisor where you can create multiple virtual machine, and you can have your own operating system on every virtual machine, and then you can start hosting your application, right? But our idea was to host applications, every service in a different server, and because of that we started using virtualization and VM and lots of operating system. Okay, can we so if we want to host our application on the server in an isolated way, okay, but without doing virtualization, if we can do that, we'll do it, right? And how can we do it? With containers. So containers are very small stripped down version of any service. Okay, so the best part is it's isolated. It can run as a service in any operating system, in Linux operating system or a Windows operating system, right? And this one more problem that container solves that we have not discussed yesterday. Okay, the problem is this we already know that it's small, very lightweight, can be easily shipped. Very good. But what do we achieve with that? The main purpose to do that is whenever, if you take an example, whenever we are giving any application to deploy on any server, okay, with application comes with some prerequisite, okay. So let's say developer has created one Java application or a .NET application. So before deploying that application to any server, we have to install some software, some prerequisites, some libraries, right? We have to change some configuration files. We have to do so many things on the server, and that's the work of the admin. Sysadmins will do all this work, installing all the prerequisites, changing all the configuration file, right, and then deploying the application. Right. Now, in this process, what happens is there is miscommunication, and because of that, some prerequisite gets installed, some doesn't get installed. Okay, some get installed of a different version, so your application doesn't work properly, and then the problem comes, we call it as finger pointing, that the code, the application works on my system, but it doesn't work on a production system. Okay, so problem is with the systems and not with my code. Okay, and the operations people will say that we have deployed as per whatever you have said, right? But maybe due to version or due to some other prerequisite issues, the application is not working. So if we can ship our application with all the prerequisites bundled inside it, okay, I think about it from a VM point of view. If you think, I want to deploy an application, so I install all the prerequisites in a virtual machine. I deploy my application in that, right? And then it's a virtual machine, so I can kind of shut down, zip it, and send it across. But we can do it for one or two. But what about when you have a lot of hundreds of applications that needs to be deployed on hundreds of servers? Okay, that's a problem. Virtual machine size is huge, even though it's just set of files again, but its size is huge. Okay, it's not easily shippable. Okay, it's bulky. But when it comes to container, it's very lightweight. Okay, stripped down version doesn't need operating system inside. It uses host operating system. Okay, so we can easily ship it, like in real time when we ship the containers on the ships. Okay, and we take it on board on the ship, and then we land it on the dockers, right? I'm talking about the ship, like real ship where we have real containers and real docks, right? So that place we can quickly put everything inside the container, ship it on the other port or other dockyard, right? And then it's easily deliverable. Okay, the same funda is used here, and that's why the same name they use, like Docker, which can host all your containers. Okay, and it's easily shippable. Okay, very lightweight. Right, so we already compared this with hypervisor architecture. Right, so we can do that with container. Yes, we can do that, right? But with that comes with lot of operations work. We have to do so many things manually. So Docker help us to do that. Okay, Docker kind of automate so many things internally itself. So you don't need to worry. You just take the container. You use Docker to build the container or build the images. You can use Docker to host the containers. Okay. So Docker is a project from Docker Incorporation, which is open source software, and there are multiple software inside that. Right, going again into the history of Docker. So Docker is a company which gives us the Docker project, which is open source. Anybody can contribute to it, and Docker Engine is the main software in that, which can host containers, which can create containers or images. Okay, and we can integrate so many other software, Docker software with Docker Engine, also third-party softwares with Docker Engine like Kubernetes. Okay, so yeah, and the biggest USP of Docker, I say, is the Docker Hub, where you have already pre-built images, or we can say pre-built softwares. So let's say I want to release a software now. Let's say Red Hat has come up with a new software and it's going to release that software. Okay, with releasing the software comes the documentation of how to install the software and how to do all the prerequisites and all those things, same things, right? Now instead of that, Red Hat can ship a container. Red Hat can create an image of that container and ship it. Anybody who wants that software can simply pull that image and run it as a container. Doesn't need to do any prerequisite, nothing. Okay, like this, if you search for different software that you have already used in your real time, in your company, in your organization, take example of this course itself. We talk about Jenkins. Okay, to set up Jenkins, we need to do some prerequisites. Can we run it as a container? Yes. There is an image available. Yes, on the Docker Hub. Like that for Tomcat, Nginx, MongoDB, MySQL. So you don't need to do any prerequisites, right? You pull the image from the Docker Hub and you run it. That's all. Okay, very easy. So Docker Hub is a place which hosts a lot of images, image repository, and you can also have your own image repositories, a public repository or a private repository, right? The funda is same like GitHub, private and public. Okay.
Imran, quick question.
Yeah.
So you said the container is light version of the software, right? Operating system. So when it is being shipped as a container by any vendor, for example, Red Hat or Oracle or whoever it is, right?
Right.
So would that be the scaled down version? Because every individual requests are different, right? Because I might be needing for my application something else, more binaries, whereas someone else might need some more extra binaries or whatever, right? So how is that container? Is that a full-blown version or it's a light version?
Very good question, and your answer is right on the screen. I was about to discuss the same thing now.
Okay.
Okay. So what happens is these are the pre-built images which you can use, but as you said, we want some more software inside that. So let's say we have pulled a MongoDB. The symbol of a leaf you see over there is a MongoDB symbol actually. So let's say I have a lot of customer who uses MongoDB, okay, as a NoSQL database. So I can pull an image from Docker Hub, okay, and I can run a container from that, and I can customize it according to my requirement. I need few more configuration, few more libraries inside that, right? I run a container, I do all the changes inside that. After that, I commit the change, okay, and I create an image from my latest container that I just modified. I'll create an image from that container, and then if I want, I can host that image on Docker Hub or any private registry if I want. Okay, now if anyone wants a MongoDB customized image as per the organization standard, okay, so as per your organization standard, you can keep a MongoDB image, customized MongoDB image on a Docker registry or any registry if you want, and whosoever wants it can simply pull that MongoDB container, okay, image, and run the container. Okay, so for that registry plays a major part over there, but I would say without registry also you can do that by committing all the data to a container and then creating image and you can ship this image. You can also copy it through any mechanism. You can literally create a zip file like tar.gz or a zip file and copy that to anywhere you want. Okay, but registry plays an important role over there, just being a centralized place which can host all your images, your customized images. Okay, you can version your images like we version our artifacts. So instead of we create an artifact and release it, we're going to create images, version it, and release it. Okay, and this is a real-time example which actually I did it for so many customers, because back then we had few customers, like a lot of customers who needs MongoDB most of the time. This is what we did from the organization point of view. We customized it and we used to ship it. There's one more example I'll tell you of Jenkins, okay, which we'll take. Okay, customizing Jenkins according to our need and shipping the Jenkins image to all the customer for the DevOps solution. Okay, we will take that. Okay, so right, so that was all about containers and Docker's theoretical part. Now you should understand the automated workflow. Being a DevOps, you'll create a continuous delivery pipeline. Okay, and we have already discussed. We take the source code, we build the source code, we create the artifact, then we host the artifact to a repository like Nexus, and from there we use Ansible or any other tool to deploy it to hundreds of servers. Okay, but when it comes to a container or hosting images, it will be as you see on my screen. So let's say a developer has written some code and will, instead of creating an artifact, here we are going to create an image. Okay, the software repository like GitHub is being used. The code is being built and tested, and as we generate an artifact, here we are going to generate an image, and we are going to host that image. We'll version that image and we'll host it on a registry, Docker Hub or any private registry, and from there any tool like Ansible, Chef, Puppet, or any scripting can pull that image and deploy it to any of the server. Okay, can deploy it on the physical server, can deploy it on a virtual machine, can deploy it on the cloud computing providers like AWS, Azure, and Google Cloud. Okay, so this is going to be the automated workflow. The only difference is, instead of generating a plain artifact, we are going to generate an image. Okay, and ship that image. Okay, so the benefit of this is you don't need to with the configuration management tool, we do all the prerequisites, installing of packages, restarting services, changing configuration. So that part will be gone. Okay, because your image contains all the prerequisites. You just kind of ship it, run it. That's all. All right. Any question?
Sorry, Imran. Yeah, sir. One more question there. So what you said is the developer would create an image, right?
Right.
So is that after testing and everything is done, or
Yes.
where is that? Where is this fitting into the main big picture of DevOps? Because Jenkins and all, right? Someone checks in the code into the GitHub, and Jenkins will pull that and do the build and all that stuff. And
Right.
So where is this app is coming? Is that after Jenkins and all that stuff?
If we talk, I would take an example of Jenkins. So Jenkins, we build and we create artifact, right? And the Jenkins itself, we build our code, right? And in the image, and we'll create an image, we'll deploy our artifact into the image, into the container. We create an image there and we ship the image. So that is being done by, there are tools to do that. In Jenkins also you can do, there are Docker files. We'll see, once we go to Docker file, we'll see how to build an image, and we can ship an image. And there are plugins in Jenkins to do that. Okay, so every source code, let's take example of the source code that we built, okay, which contained all the Java source code. In that will contain something called as a Docker file, which we'll see, which we'll do it in some time. This Docker file will have all the information how to build this particular image, what code to be deployed, what prerequisite to be done, and all those things.
Okay.
Okay.
Yep.
All right. All right. So now let's go and look for the Docker Hub repository. Okay, so that's the Docker Hub repository, registry, we call it in Docker. These are some official registries you see, official repositories like Nginx. So if you go, you can download Nginx software separately and install it, or you can take image and run it as a container. Okay, Redis registry, Postgres, there's so many of them. Okay, if we search for our favorite Jenkins, which you already did. Okay, if you click on this, so it will give you an information of how to run this particular image, right? So Docker run command is used to run image, container from an image. Okay, so this is the command we can use to run it. Okay, I'll explain it to you what all those options means slowly. Okay, it contains so many other information which over the time you'll understand. Okay, once we do Docker file and all. So see, you should be aware of an official repository and a public repository. Okay, you can have your own, you can create your own account, which you'll do, and you can host your images over there. If you don't pay anything, it's going to be a public repository, so anybody can pull your image. Okay, if you pay some amount, all right, you can have a private repository there on the Docker Hub. Okay, there are so many official repositories which comes directly from the vendors. Like Jenkins is a vendor for Jenkins software, so they'll also create an image for their software and host it on Docker Hub. So that's the official repository. Okay, so if you see in the first page itself, we have all these official repository. So you need to be careful from where you are pulling. If you official is definitely can be trusted. Okay, it's like you trust their software, you trust their image. Okay, like that. When it comes to some public repository, you have to be sure whatever you are using, all the image that you're using is bug free and there's no security concern with all those things. Okay, or either you can take any of your image and create your own image from that. Okay, which will be see. Okay, so let me open my terminal and show you few things about the images. Okay, so Docker images is the command which shows the downloaded images you have. Okay, Docker pull, and you have to give the name of the image. Let's say we want to pull Jenkins, so we can give name as Jenkins. So by default, Docker pull command is going to go to the Docker Hub registry and pull that Jenkins image. Okay, now to pull an image, I also talked about the versions of it. Okay, so if I say colon latest, which is default, even if I don't provide, this is a tag. Okay, the right hand side you see after the colon is called as tags. So tag is like version. You can simply say it as a name that they have given for that particular image. So mostly this name is given according to the version. If you see, most of the tags over here on my screen is latest. Okay, now latest tag does not mean that this image is latest. It means simply the image with the title of tag, okay, is considered as the latest one. Okay, if I want to take a particular version of it, okay, so let me share the entire screen. Okay, let's take an example of, let's say, MySQL. Okay, now here if I want to pull MySQL, if I say Docker pull MySQL, it's going to pull an image with the latest tag, even if I don't provide it. That's the default one. So if I give latest or not, it's going to pull the latest image. But if I want to select a particular version, I can see different versions of it, supported tags and respective Docker file links. So let's say I want to take 8.0.0 or 8.0 or 5.7, so I can provide it like that. Let's say Docker pull colon let's say 8.0.0. It will first go to, now these tags are listed there, but this image with this particular tag should be available there. If it's not available, we're going to get an error. If we have it, it's going to pull it. What is wrong? Am I audible? Is the internet working?
Yes.
Okay. Okay, started. Okay, now each image, or I call it generally each repository. So MySQL 8.0.0 is actually not just an image, it's a repository in itself, and this repository will contain multiple images. So any image we say, whatever you see on my screen, all these images actually are not just single image, it's layer of images, multiple layers will be there. Right, so when we pull, it pulls all these layers. So if you see, these IDs comes from those layers. So when I pull an image, it doesn't pull just one single image, it's actually combination of multiple images layered one top of other. Okay. So depending on the size or your internet speed, it takes time or not. Okay. 68 MB. Okay, that's big. Okay, that is done. Okay, now let's list it. Docker images, and where is MySQL? Yeah, here is our MySQL, and it has a tag of 8.0.0. And if you see the size, it's 426 MB. Okay, it's pennies. I mean, very less actually. You know, this like a size of a software. Okay, but you get a full-blown MySQL server, okay, running with all its prerequisites and libraries required to run. Okay, all you need to do is just run a container from it, and you can start using it there. Okay. Okay, if you want to remove a particular image that you have downloaded, you can simply say docker rmi, and you can give the name of the image. So while removing the image, let's say I give Ubuntu, and if I say docker rmi Ubuntu, it's gonna remove the latest one. So if I want to remove it, I can give a particular tag. Let's say I want to remove this Ubuntu image with 14.04 tag, and it's gone. Right? Okay. Now, that's something about images. We can do so many things with images. Okay, we'll see how to build the images also. But before that, we'll see few bits about containers. Okay. Now, docker run is a command to run a container. Okay. Now with that comes a lot of options. If I say docker run --help, so it's like this. Okay, so what all you can do with docker run command is, so let's say first let's run docker run -it. Now -i is for interactive mode, T is for TTY session. Okay, now when I say -it, I'm saying that I want an interactive container where I can log in, where I get a shell. Okay, that's what I'm saying. Remember one thing, we run a container, but we don't need to log into that container as we log into any other server. Like logging into the server and we do some changes, no. Okay, it's a ready to eat package. Okay, we pull it and we run it in the background. Okay, and every container, this is the best practice, that every container should run only one service or only one process. Okay, and if that process is forking some other process, that is fine, but you do not run multiple services in one container. Okay, one container, one service, that's all. Okay, and you do not need to log in, but I want to show you how to log in. So you can say docker run -it bin/bash and the name of the image. Here I have logged in. Now what did I say is docker run -it and the name of the image, and I say bin/bin/bash. That means I want to run a bash shell inside this container. Okay, because this particular image, Ubuntu image, doesn't run any service. So if I don't provide any service, it's gonna simply open and die, because every container needs minimum one service. Okay, keep this in mind. It needs minimum one process to run. Okay, and that's bin bash process for us. So if we say ps-ef, I'm inside the container. Okay, so bin bash is the process which is running. Its PID is gonna be 1. Okay, any first process that starts inside the container will have a PID of 1. Okay, this ps-ef was a process, but it died. Okay, this is the same command that we ran. Right. So if you do not provide this bin bash while running this container will not run simply. Okay, I've shown you that if I do exit, I kill this container, because while doing exit, I kill this bash shell, which is the main process. Okay, if the main process dies, the container also dies with it. So I say exit. So docker ps is the command which shows the running containers. Okay, I say docker run -it bin bash. If I do it again, it's gonna open one more container. Okay, it's not gonna run the same container, it's gonna run the next container, the other container. Okay, so I'm gonna say docker run -it again, and I open this. Now you say, now how do I come out of this? Now I have logged in, but I want to come out of it. I don't want to do exit, but if I want to close a shell, I do exit. Okay, so the option is Control P and Q. Okay, and I say docker ps, and then I see the container is running, and the command is running. The command which is running inside this is bin bash. Okay, a bash shell. This is the container ID. Okay, let me expand it a bit. Docker ps. Okay, so every container will have an ID, the image name from where it started, the command that it's running, the main process. Okay, the main command which it is running, the first process. It will tell you when it was created 40 seconds ago. The status is up from past 38 seconds. Okay, it is not showing us any ports, and this is the name. The name is Reverend underscore Noether. Okay, so if you do not name a container, the Docker engine is gonna decide some name to the container and give it to. Okay, so now docker ps shows me the running container. Okay, if I want to dock it, if I want to get attached to that session again, I can simply say docker attach. See, I'm showing you attaching and detaching from a container, but in really you don't need to do all those things. Okay, you will only do this if you are doing some troubleshooting or something. Okay, so docker attach, and I give the ID of the container, or I can give the name of the container. Okay, docker attach and the ID, and I am in. Okay, if I do exit again, it will die, but I do Control P Q. Okay, Control P Q. Remember this. Docker ps, it's running. Okay, now let's say I want to stop this container, so you can simply say docker stop. You can give the ID of that container. Then if you say docker ps, the container is stopped. So where did you see the stopped containers? You see docker ps-a. Okay, these are all the stopped containers, exited containers. Okay, can I start those containers, stopped containers? Yes, you can start it. Okay, let's take example of the container which you just stopped. We can simply say docker start, and we can give either the ID or we can also give name. This time we'll give the name. Okay, and let's again see with docker ps command, and it started. Can I attach it again? Yes, I can. Docker attach ID is same, and I'm attached. Okay, and this time I'll do exit. Docker ps, I don't see any running containers. I see all the stopped containers with docker ps-a. Okay, so the number of time I give docker run, so every time I do docker run, it's going to create a new container. It's not going to start the same container. Okay, just you have to be sure. All right, any question in this before I move forward?
Hi, Imran. One question. Like, so Docker attach is to connect to that existing image, and
Existing
Docker
container,
sorry,
not image.
I mean, yeah, and sorry, a container, and a Docker run is to create new container, right?
New container. That's correct. That's correct.
Yeah, got it.
With the same properties, right? With the same properties that we initially, means the same set of libraries and all that.
Yeah, see, whatever is in the image, that will run. That's all.
That will run. Okay.
Yeah.
Okay.
So it's like packaged food, right? You open any packaged food, right? So every package, like let's take example, I don't know, some cup noodles of some brand. If you open any package, it's gonna give you the same thing, right? Exactly same configuration. Okay, open it and eat it. Okay. Now I'm using Ubuntu container, and trust me, really, this image. Sorry, I'm using Ubuntu image, and this image is really not used for anything other than just creating other images. Okay, this Ubuntu image, because it doesn't run any service. Okay, we use container to run service. Can you please mute yourself? I'm hearing some echo. Oh, sorry, background noise. Okay, thank you. So Ubuntu image doesn't run any service really. Okay, all we are doing is we are sending some command to it, and then only it's giving us at least a shell. Otherwise, it doesn't do anything. Okay, if you don't provide the shell, let's say we say, you know, docker run, and we say Ubuntu docker ps. There's nothing running. Docker ps-a. Okay, it says 7 seconds ago it started and it died. Okay, because it doesn't have anything to run. Okay, no service to run. Okay, in real time, let's take an example of now Jenkins. Okay, let's find out our Jenkins and we'll run it. Come on, Jenkins. Okay, how do I run it? How to use this image? You can do it like this. Okay, now okay, we'll understand what are all those things options. Okay, so Docker images, I already have a Jenkins. So let's say if I do Docker run and I don't have an image locally, it's gonna download it. So we really don't need to pull every time. Okay, if you don't want to pull, it's okay. It's same like, you know, Vagrant box. If you don't have the box and we do Vagrant up, it's going to read the Vagrant file. If the box is not available, it's going to download it. Same thing here. If I say Docker run and that image is not available, it's going to download it. Okay. Now this time we'll do some real-time work. Okay. This time we'll run. Okay. First of all, let me sudo service Jenkins. Okay, so I was checking whether that Jenkins service is already running or not on my machine. Okay, this time what we'll do, let's say you want to have a Jenkins server. You don't need to create a virtual machine and install Jenkins and do all those things. You can simply pull an image and run it, and this is how you can do it. Docker run -p 8080, sorry, colon 8080. Okay, what does this mean? -p is for port forwarding. Okay, now we know Jenkins service or this particular image, if it runs, it's gonna run the Jenkins service on port 8080. Now that port 8080, right side is of the container and the left hand side is of the host. Okay, so the host port 8080 is mapped to container port 8080. Okay, you can choose to give any port over here if you want. Okay, let's say you give 9090. That is host port, okay? But your image is definitely going to run on port 8080. Okay, the Jenkins service is definitely going to run from this image on port 8080. Okay, now if you want, we can expose few more ports also. Like this image also runs exposes port 50,000. Okay, so you can say 50,000 maps to 50,000 ports. So this is right hand side is the port of the container which is going to run. Left hand side is the host port. You can choose to give anything. Okay, we have choose to give 50,000 only, and we give the name of the image Jenkins. And I say docker run -p da da da, enter. And what actually is happening on my screen is it started a container. It is displaying everything on the screen. Okay, you see Jenkins initial setup is required and admin user created and password generated. So it also generated a password. What if we install the Jenkins? We have to go in var lib and that file and find out this password, right? Initial setup of Jenkins. Now you cannot do that with the containers. Okay, so it shows you on the screen. Okay. All right. So we have exposed it on port 9090. If we say local host colon 9090, and we land up in Jenkins. Okay. Cool. It has also acquired my shell. Now I cannot do anything. It has taken my shell. I'll take another shell now. New terminal. Okay. I say docker ps and I see a Jenkins container already running. Now how can I use? Same way how we used our old Jenkins server. Similar way you can use this Jenkins service. Okay. But the only difference is this is hosted on a container. That Jenkins which we created was hosted on a virtual machine. Okay, but it's going to serve the same purpose. It's very lightweight. You simply run it and you're done. You don't need to install Java, this, that, blah, 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 blah. Okay, if you want, you can install some other software also in this. Okay, but not like this, like we install it on a virtual machine, you know, apt-get and do all those things. For that, we're going to use Dockerfile. Okay, we'll see what is Dockerfile. All right, so this is the ID, right? The name of the image, and it's running some command /bin tiny user low blah blah blah. Okay, it also shows the port. Okay, 50,000 is mapped to 50,000 and 9090 is mapped to 80. Okay, I told you you can also get the IP address of container. So docker inspect is a command which shows you all the detail about a container or a image. Docker inspect, and I say doc, and it's showing me so much of information actually. Okay, some of them you will over the time or the period of time you'll understand. Most of them you'll ignore. Even I ignore those things. Okay, so that's the IP address of the container. Okay, it's coming from this gateway, which is actually a Docker zero bridge. If I say ifconfig on my host machine, I'm on my host machine, I'm doing ifconfig, and like I have interfaces like, you know, wireless interface, WLO1, Ethernet interface, like that I have a Docker zero interface. Okay, it's a virtual interface which gets created by default when you install Jenkins. You really don't need to do anything with this. I'm just giving you, this is just an FYI, okay, for your information. So this is the gateway for all the containers running on my machine. Okay, so Docker inspect gives me the IP address of my container. So I can use this IP address also if I want. Okay, let me copy this and I say 8080. See, same thing is happening. Okay, so port forwarding is allowing me to give the local host or the IP address of the local machine and give the port number which it is mapped to, or if I want to hit the container directly, I have to give the container IP and then the port on which the service is running. This is a very bad method. Okay, never use this. Do not rely on IP address of containers. Okay, containers come and go, their IP address change, and there's so many things that happens. Okay, so always you have to give the IP address of the host machine where the container is running. Okay, let's say you're running this container on a server which has an IP address of 192.168.1.22. Okay, and the container IP address is this one, 172.17. Okay, don't go with the container IP address simply. Okay, I'll not show this you now. Okay, so you have to give the host IP address where the container is running on this host machine and the port number on which your container is mapped to. Okay, this is a very important concept. This is called as port forwarding, which Docker engine will do it for you by default. Okay, you don't need to do anything. So if you do containers manually, then you have to set up all those things manually. Okay, but Docker is giving you nice command. You simply give it what port is mapped to what. That's all. Okay. So initially it may take some time for you to digest, but once you start running few containers and start hitting its service, you'll understand. You have to give the host IP address and the port which it is mapped to. So when we executed Jenkins container, where is that? Okay. On the screen. Executed Jenkins container, we said port 9090 of the host is mapped to port 8080 of the container. Okay, so we can hit localhost 9090 and we'll get the service. Okay, all right. So if I close this shell or if I do Control C, this container will die. All right, which is very bad for me. Okay, I don't want something running on my screen. Okay, and I have to keep that screen open all the time to run that service. No, I don't want that. So I'll use some other method now. Let me first close this. Control C, because I had no other option. Okay, what I can do is, so if I say docker ps, now it's not running. Okay, if I say localhost 9090, okay, it's down, dead. Okay, now let's do this. Let's run it again, but this time we'll give one more option which is called as -d, which you're gonna do it all the time. Okay, -d option is called as detached mode. Okay, run the container in a detached mode. Do not attach any terminal, even if it is asking. Now this particular image, when we run it, asks for a TTY session. Okay, and it takes our session, it takes our shell. I don't want that. Okay, just run it in the background, I don't care. Okay, -d, it returns an ID of the container. I know we'll say this is a very big ID, but actually this is the real ID. What you see with docker ps is a part of it. Okay, this part of it. Okay, actual ID is very big. Right, now it's running in the background. Okay, want to test it? Let's refresh this, and we got it. Alright, -d option is used to run it in a detached mode. Alright? Okay. Any question?
So if the container is stopped and once again if it is started back, whether the container ID will change or not?
It will not change. It will not change.
What about IP address of that container?
No, it will not change. So let's see. Docker ps I have given. Right. Let's stop it. Docker stop. So see, very rarely you worry about IP address. First of all, do not even think about using containers IP addresses. Okay. Just Docker decide what IP address it gets, and Docker will do all the internal networking. You do not even need to see the IP address. You don't require to actually. Okay. So let's say let's stop this.
I can't see the screen.
Oh, sorry. Okay, so I have stopped it. Docker ps -a, and I see this one, and that's the ID, right? I stopped it. So if I say docker start, I'm giving the ID itself, so ID is definitely not going to change. Okay, Docker inspect. Well, the IP address may change. Okay, since this is the only running container, we are not sure. It did not change. Okay, but I would say barely worry about the IP address. Do not treat it as a virtual machine that you take the IP address and you access it. Okay, you have to give the host IP address, okay, and the port on which this container is running on. Okay, let it change, does not really matter. Okay, now just a moment. So I'll send you this document. Well, we have more to cover actually in Docker, so it's not done yet, but I'm just simply showing you this document. In this document, I have put so many things, some theoretical part, how Docker works. So basically, whatever we discussed, I have put it everything over there. Okay, plus few more things. It shows you the installation steps, how to do it on a Linux machine, Windows machine, and a Mac OS. Okay. So you'll get this document today. So what are container, how to run a container, right? So whatever we did, ps-ef, the process, images, okay? Deep dive in the image, what it is. As I told you, image is group of layers, okay? So that's what it talks about. Pulling the image, how to pull an image, okay? We have to also create our own image and then we'll push the image, okay? We'll do that, okay? That as well. Image naming and tagging, right? Image with multiple tags. Okay. One thing you have to understand is this: every image consists of multiple layers of images. Okay, and all this image is read-only mode. Okay. So whenever you run a container from any image, it is actually reading it from that image. It is not creating a separate copy and creating a container. Like in virtual machine, we download a box, and when we create a virtual machine from that box, it copies, it clones everything into a separate directory, right? It runs it as a separate virtual machine. Even the box is deleted, the virtual machine would be running because it's a separate copy. But in container, when you run a container, it runs from the image itself directly. Okay, if you delete the image, the container dies. Actually, Docker will not allow you to delete an image if a container is running from it. Okay, now what happens if some write operation happens? Well, all the images there are in read-only mode. If you try to add any data, okay, let's say you created a container and you install some software into that. Okay, that means you have written some data in that container. Now that will create one more layer on top of it, which is going to be read-write mode. Okay, it is not going to edit the existing layer. Okay, existing layer will always be in read-only mode. Okay, this you have to understand. Okay, every layer is going to have an ID, okay, which Docker will decide. So you really don't need to worry on it. Like we did Docker inspect on a container, if we do Docker inspect on an image, okay, it shows all the detail of the image, how many layers it has, okay, or so many other information from what is the base image and all those things. Okay, sharing the image, I told you, you can pull the image from a Docker registry. Okay, and we can also share any of the image that we have, okay, through hosting our own registry or own repository, okay, on Docker Hub or any other registry. So before that, we need to know about how to create an image, okay. So we'll do that once we know how to create our own image. Then we'll post it. And Docker RMI is the command to remove the image. We have not seen how to remove a container. Are you seeing my terminal?
Yes.
I have shared my entire screen, right?
Yeah, we can see some document by the Docker document.
Okay. So I have opened my terminal now, and with Docker ps-a, I see a lot of dead containers, okay, which I don't need. So if I want to remove that, I can simply say Docker rm and I give its ID.
Imran, we can't see the terminal.
That's what I asked. Say Docker ps-a, and I see a lot of containers there. Okay, dead containers. Okay, stopped containers. So if I want, I can remove it by giving docker rm, and I give the ID. Actually, there is one more way to delete all at once. I'll show you later. Right. So docker rm command you can use to remove any container. You can give the ID of the container, or you can give the name of the container, but the container should be stopped. Okay. If the container is not stopped, then it will ask you to stop a container.
What's the difference between detaching and stopping? Would it remain the same ID even after
No, see,
restart
detaching detaching, attaching, we do it on a running container. A container is running and we attach to a container and we detach. Detach or attach doesn't mean that we are doing any operation in the container. We are simply attaching a shell. Okay, we are just like a login. Okay, where remove is like removing, or sorry, stop is stopping, like we stop any service. Removing is like removing that particular container, deleting it. Okay, attaching, detaching is simply used to run attach to a running container.
So even if we detach, the service would be still running.
Right, it will be still running.
All right, thank you.
But, quick question: like in the container, what it doesn't have any operating system, right? If you have a Jenkins image, if you have a container with Jenkins image, how is it running Jenkins then? Means what is the thing which is it's something?
So as I said, it uses host operating system kernel. So my Ubuntu operating system, my desktop operating system is Ubuntu. I am running container on that. So these are just set of files which is accessing, which is using my operating system kernel.
Okay, so if you run ifconfig, then every container will have one kind of IP address then?
Yeah, but ifconfig command will be removed by default from all the containers because you don't need to check IP address.
If you run ifconfig in the host operating system, then will it show for every container one kind?
No.
One IP address?
No. ifconfig on my host operating system just shows the bridge, Docker 0. Okay, this bridge is like, you can think of, it's a router for them. It's a router for all the containers.
Oh, okay.
Okay, or a switch.
Okay.
So you want to see the IP address of the container, you do Docker inspect. Okay, but don't worry about IP addresses and all. Okay, you are not going to identify container with IP addresses. You are going to always identify container with a name.
Yeah, and like just curious to know, like what kind of issues like containers generally get in production systems, in production environments. Because this is completely very lightweight and one container, one service, and I don't see any kind of issues. Like what kind of issues we get and what kind of things we normally do in production.
See, mostly the issue doesn't come from the container. Mostly the issue comes from the host operating system. See, you can think of container as a service. Okay, it is actually a service which is isolated. Okay, like you can install Jenkins service on your host operating system and run it, right? If you run a container, it's going to be same thing, but that particular service is very isolated. So whatever issue a normal service have, right, the same issue a container can have. Okay, so service as in if the package was not built properly, it was not able to handle that many requests. If the image is not handled like it's not designed like that, it cannot open so many files. Then these are application related issue that comes, like a normal application. If you run on any server, what issues it comes, right? What issues it gets is similar to that. But mostly we see the issue is not with the containers. mostly the issue is with the host operating system. Okay, sometimes what happens, people just keep on hosting containers without even seeing the memory size of it. So we kind of monitor the memories and all those things. Okay, so similar like we monitor a normal physical server, we monitor the Docker engine. These are some issues that comes.
Yeah, okay, so got it. Yeah, thank you.
And Imran, in real time, where this exactly Docker will be fit in continuous delivery pipeline or continuous integration pipeline?
You're not audible. Can you speak louder?
Yeah, where this Docker exactly fits in our continuous integration or continuous delivery pipeline?
See, Docker is going to run the container. When you talk about continuous integration, continuous delivery pipeline, that time we create images. We'll see that tomorrow, creating images. Okay, so we can create images from Jenkins also, we can create images manually also, we can use Docker file, other software to create image. That time we need a Docker engine, okay, but Docker installing, keeping Docker engine on any of the operating system is piece of cake. Okay, you can simply install Docker engine and keep it, and you can start building images. Okay, so let me open this. Right over here, if you see, let me make it full screen. So over here, if you see here, once we create the artifact, once our artifact is created in our continuous integration or continuous delivery flow, if we check out the source code on Jenkins, we build that particular source code, we create an artifact, and that artifact we are going to deploy it into a container. We'll create an image of it, we'll version it, and we'll ship that image. Okay. So at that point of time, let's say you are building an image on Jenkins server. So that time Docker engine has to be running on the Jenkins server. Understood?
Yeah.
So anywhere we want to build an image, we need Docker engine there. Okay, if you question Docker and Docker pull commands are same. Shrikant, Docker run is to run a container, Docker pull is to pull an image from Docker Hub registry. Whenever you see Docker run, it is definitely to run a container, that's all. For the container, Docker pull is for images. So you can divide Docker broadly into two categories. One category is images, where you create an image or you ship an image, you version an image, right? You do all the operation on the image. And the other category, you can think of it as container. Okay, running a container from that image, okay, managing that container, assigning ports to that container, attaching a container, detaching a container, right? All those operations that you see on the container, right, comes on the container category. Where is that document? Actually, I got diverted. Yeah, just a second. So we'll again go through this document. So this is fully customized document that I have put so many things from here and there. Some I have given of my own. Okay, it's not a ready-made document. Okay, but I'm going to share this with you. So you'll see all these things. Just a moment. Container process, stopping containers gracefully. Okay, you know how to stop a container gracefully. Docker stop. Okay. So we have not seen how to name a container. We have seen every container that we create gets some name that Docker engine gives. Okay, but by giving simply hyphen name and any name of your choice, you can run a container. Now I said of your choice, but when you are running a microservice architecture where you have a lot of containers, okay, that time every container is going to identify each other with the name and not the IP address. If you talk about connecting two containers together, let's say there is a web server and there is a DB server container. Now, in generally what we do is, in web server we give IP address of the database server, and that's how web server identifies the database server. But I already told you, you are not going to rely on IP addresses because these things are going to change. Then how do you give the address, right? To find any server on a network, okay, no matter it's a virtual or a Docker network, you should give some information, right? Like IP address or a host name. So it's always going to rely on the host name and not the IP address. And a host name, you are going to assign it to it. So this is not going to be just a name for the namesake. Okay, this name. So let's say some developer has written a web application, and the web application inside that needs to connect to a database server. So inside that, the developer has to give the name of the container. Okay, and while you run the database container, you have to give -n name and the name of the container that the developer has provided in the application server. Okay, a very simple thing. All the containers going to identify each other with names and not IP addresses. Okay, so -n name is a very important thing.
So it's like whenever we exit from the container, the IP address is going to change. So that's why we'll give the host name, right?
Yes, yes. Or see, it's not only about the IP address change. When you create an image, right, and you ship the image, like you ship a bundle of images. You ship 10 images which are going to interact with each other. So all these images, you will hardcode that it will identify each other with its name. So you will say this is the name for all the containers that should be running.
So suppose if we give a same name, will it identify like name already exists or something? Will it throw any error?
Yes.
Okay. Because there will be hundreds of containers, right? Sometimes we might.
Exactly. Right. So you have to come up with some name strategy first of all.
Yeah. Okay.
Okay. So here I'll close it. Last command. The rest of the thing we'll take tomorrow. So if you want to remove all the containers, as I said, in one shot, you can do it like this: Docker rm. So all the dead containers, by the way, okay, or all the containers. Docker ps. You can give this command -f, and it's gonna remove all the containers. Okay. Rest of the thing we'll take tomorrow. I have to get into other class. Okay, if you have any question, please do write it down and ask me tomorrow. Okay, you'll get this document by today. Okay, just go ahead, start installing Docker and start practicing it. All right. See you tomorrow. Take care. Bye bye.
Thank you.